A relatively common problem you may encounter is the need to cut a sign or design that is larger than the available material, or in fact the machinable area on your CNC router bed. So to demonstrate how you can deal with this problem, I've got an example sign here that's pretty large. It's 72 inches by 48 inches here, so that's going to be larger than most people's router beds. And what I'm going to do, I'm going to just look at the 2D and 3D view together, and then I'm going to cut across and focus a little bit now on the toolpaths that have been created for this sign. So let's start and get a feel for what the sign looks like. So I'm going to turn on all the toolpaths here and just preview them so that you can see the final result. And I've got a little extra cutout here that allows me to separate the sign from the material from which it's been cut, and that means in the preview mode here I can double click on the area and it'll delete it as waste material, and we can see the finished sign. So you can see the sign comprises quite a few different elements. It's got some pocketing, some V-bit work to bring up the edges here, some raised bevel text sitting inside again a pocket with some profiles and cutout passes. So there's quite a few toolpaths involved in this job, but the important thing to emphasize at this stage is, despite the fact that I know I can't machine 72 inches by 48, I don't need to worry about that during the design process. So the design process has been done for this sign as if it will be manufacturable at that size. And it's only now that I come to think about how outputting my toolpaths to my machine tool that I need to worry about the fact that I'm limited by my machining, say, my router bed size. And so for the purposes of this demo, we're going to assume, for example, that we've got a router with only a 24-inch bed size. So it's only got a 2 foot by 2 foot machinable area. So how do we deal with this sign? Well, there's a set of functionality that's all accessible here from the Tile Toolpaths command, which is on the Toolpaths tab on the right hand side. And when I switch that on, we get a Toolpath Tiling Manager, and this allows us to break the toolpaths up that we've created into panelled sections. And this will allow me to take my sign and cut it as a series of 24-inch panels, such that at the end I can assemble those panels to make my finished part, and that allows me to work around the limitation of my machine bed. Similarly, you might only have, although you might have a larger machine bed, you might only have material pieces that are 24 inches in size, and so the same situation really arises. Okay, so how do we go about doing that? Well, it's much simpler than you might first imagine. We have simply an option here that says Tile Toolpaths. Now this manager you can show and hide, but the crucial fact is whether or not you have this option switched on. As soon as we switch this option on, the software goes ahead and divides any toolpaths you've created into a series of panels. Now it's not very exciting at the moment, because if I turn these toolpaths on, we'll see that it doesn't seem to have done much. That's because at the moment it's automatically found the full size of our job, and we're going to edit these values now to tell it what the size is that we require. But first of all, I'll just mention at the top here there's three options: individual tiles, feed through in X, and feed through in Y. Now the feed through options are really for the situation where you have a long thin design and you might have a gantry type router, and in those cases it's quite convenient if it will fit on your bed in one dimension and is just too long. With a gantry style router, you can imagine that you can cut this section, then unclamp the material, feed it through the same piece of material, reset the origin and machine the second part of the sign, the middle piece of the sign, then draw it through again and cut it again. And this system is really handy because you end up with cutting effectively a single piece of material. You're just doing it in bite-sized chunks that match your machine's bed size. We're not going to focus on these for a moment. There is another tutorial that deals with an example of a mantelpiece that uses the feed-through system, which you can look at if you need that. We're going to focus on this one, individual tiles. The principle is very similar, except in this case we are going to split our design into panels in both X and Y. So it's too big for our bed in both dimensions. Right, let's go ahead and tell it what size tiles we need. We need 24-inch tiles for the purposes of this example, which is the size of our machine bed. And I'm going to leave the tile overlap for 0 for the moment. We'll come back to that in a second. And I'm going to click Update Tiles. And as soon as I do that, you can see that two things have happened. One is we're now only seeing a small section of our original toolpaths. And the 2D view has become divided and has a little overlay here with the letters T1, T4, etc. Now what these are showing us are the individual tiles, and as you would expect given our original job size, the 24-inch panel fits exactly in 6 panels. So we can, with 6 24-inch panels, we can make the entire 72 by 48-inch piece. From this point on, with the tiling manager on and the tile toolpath option selected, our toolpaths now, although the list hasn't changed, the sections of each of these toolpaths that we will see is going to be determined by which active tile we're looking at. So to make that clear, let's just look at one toolpath for the moment. So I'm just going to uncheck these. So we're just looking at, say, the cutout toolpath, just to keep things simple, which you can see the section of here. And as I change the tiles, you will see the sections of the cutout toolpath that match each tile. Okay, so it's taken all of these toolpaths and then it has worked out which sections of each of those toolpaths fit into each area and divided them up accordingly. Okay, so all these toolpaths still exist, but they are now being given to us in only the sections that are inside the tile that we want. So I've selected the tile from this drop-down list, as we saw just now, and we can see each tile as we go around that list. We can also select the tiles very conveniently from the 2D view by simply double-clicking on any blank area of your 2D view in each tile section, and that will select the same tiles. Now here you can very simply see the link between the 2D view tile and the 3D view of our finished sign. But this isn't actually a realistic view when you begin to think about it, because of course what we really want is toolpaths that are all sitting on our bed, and our bed size is only 24 inches from this origin. And the reason we're still able to see each tile in situ, if you like, is because we have there's a checkbox at the bottom here that's asking the software to draw toolpaths in the original position, crucially just for visualization. So the thing to emphasize here is that this checkbox only affects how we see the toolpaths relative to one another in our preview. And the reason for this is it's often in fact convenient when you're previewing your finished sign to make sure that everything is correct when the sign is assembled. So you can see effectively the toolpaths being calculated in the position that the assembled panel will go, and that way you get to see a visualization of the finished whole piece. Because obviously what we're actually going to end up is a stack of 24-inch pieces of material. That's what we're actually going to cut. So when I uncheck this and I reset our preview, that's now what we see. So what we're now seeing, and I've switched the origin on here so that you can see where the 00 origin is for our model. And I just turn those off. Now we are seeing an actual piece of material, an actual 24-inch panel. And whichever panel we select, we will be seeing the toolpath in the location as it will actually be as we cut each panel. So they are now effectively lying all in the same location in space. So the visualization version just allows you to effectively put the panel in the real world where it will be in the assembled final piece. And with the visualization switched off, you see the actual panel as it will be output. Now the other thing, just to emphasize again, is that the checkbox here does not affect your final output toolpath. It doesn't matter which way around you've got this switched. The output toolpath will always be correct for the actual job. So in other words, it will always be in this configuration within origin relative to each panel. Okay. So that's it. So we've got each panel now. And we can simulate each panel, preview each panel, we can preview all the toolpaths, and we will see the toolpaths just relating to each panel. Okay. If I select this one, we can see all the toolpaths relating to the bottom right panel, and similarly we can select the middle bottom panel here and see all the toolpaths relating to that. Okay. So crucially here, we haven't had to do anything very clever at all. We've just let the software deal with all the problems of dividing the toolpath up. One thing we might want to think about just from a practical point of view, if I turn these toolpaths on for a second, it's quite likely that you'll cut panels that are actually slightly smaller than your available machining size, because you're going to put on pieces and want to maybe cut out each panel at the end. And it's convenient then to slightly overrun the machine toolpaths that are creating the sign, just slightly overlap them a little bit so that you can cut back a clean edge for assembly. And that's really what this tile overlap option does. If I set that to be 0.25 quarter of an inch and update the tiles, quarter of an inch is probably a bit much as well. But now what it's done is it's created, for the 24-inch tile, it's actually created me a toolpath which is going to overrun on the top and right edge by another quarter of an inch. And this would allow me to cut tiles slightly smaller than my bed machining size, and then add an extra cutout pass to make sure I had clean edges to assemble the final sign. So the overlap is exactly that, but these tiles will include a little bit of an overrun into the next tile to the above and to the right of them. The area of the overlap is indicated graphically in this diagram, so the little grey area here shows you where the toolpath overlaps will be added. And that's just a convenient little extra option that you can use. Okay, so let's go and just demonstrate the final step really of having tiled the toolpaths and what they look like when they're saved. So for this purpose I'm just going to select the profile cutout toolpath, for example. Go to save here, and I have an option here to output my tiled toolpaths. I've got toolpath tiling on, so this option is available to me. I don't have to do that still, even at this stage. I can switch that off and we can just save these toolpaths out entirely as they were created. And this is something important to understand, the toolpath tiling. It is purely a last option, and it's non-destructive, so we can turn on and off tiling very trivially at any time, and your original toolpaths are not in any way damaged. But I am going to output a toolpath for tiling here, and I'm just going to use a standard G-code output. So I'm outputting the profile cutout pass. When I come to save this, you can see, as you might expect, that because we've tiled it, there are now 6 profile cutouts. Okay, and they are prefixed automatically with the tile number that relates to them. So when we output these sort of quite a lot of toolpaths here, and each one of these is now going to produce 6 bits, and they will relate to each of the tiles. So when you've finished outputting all your toolpaths, which is obviously dependent on what sort of post-processor you have, you need to make sure that you group together all the T1s, and that is the set of toolpaths that will do tile 1. Then you group together all the T2s and cut those, and that will be associated with tile 2. Tile 2, obviously, you'll have put fresh material on and started again for the second tile. But that's really it. So the tiling, while conceptually might seem to be quite tricky, the software, hopefully you'll find, makes it really easy. So just to recap then, we didn't create anything special in the toolpaths initially. We just created our job exactly as the finished piece will be made without making any concessions to the limitations of material or machining bed size. As we came to output the toolpaths, we just switched on the tiling manager and put in what the actual tile size was going to be, what our limiting factor was, either in material or bed size. And the software divided the created toolpaths for us automatically. And then when I came to output the toolpaths, I made sure that I had output tile toolpaths checked here, which it will be by default if your tiling manager is switched on. And then just understand that the toolpaths that result will be divided according to the number of tiles needed. Okay, and they will be prefixed with the tile number. Okay, and that's it. That allows you to use your smaller machine or limited size material to make much bigger jobs.